In this lesson, we're going to learn about the properties of linear relations, and we'll be able to determine if a relation is linear based on the graph, the table of values, or the equation. So from a graph, you can tell that it's a linear relation if you simply just have a straight line. And from a table of values, you will want to actually calculate your rate of change. So let's look at some examples here. In this first example, I want to calculate the rate of change. Now, if we look at the rides at the CNE, the number of rides, these are all going up by 1. And then looking at our cost, we need to find out how much our cost is each going up by. So we can do that by doing the row below minus the row above. So 7.75 minus 7 is equal to 75 cents. And I just did, I'll write it right above, the row below, 7.75 minus the row above. And we can do that again, 8.50 minus 7.75, and we get 75 cents. So our cost is all going up by 75 cents. And since the number of rides is all going up by 1, this is in fact our rate of change. It costs 75 cents for one ride. And since the change in the cost goes up by the exact same amount for every one game that's added, that means that this is a linear relation. So let's actually try the next one. Here we have a table and we have our x values and our y values, and we can see that our x values are again going up by 1. So let's find out what the change in our y values would be. And again, you would just do row below minus row above. So 465 minus 455, that's just 10. And 485 minus 465, well, that's 20. 515 minus 485 is 30. 555 minus 515 is 40. And then 605 minus 555 is actually 50. So the change in our y values are not going up by the same number. And since these are not going up by the same number, the rate of change is not constant. This is not a linear relation. So this is non-linear. And one thing to note, when we have a table of values and our x values are all going up by 1, and then we can find the differences in our y values, those differences are known as the first differences. So since this table, all the x values are going up by 1, these are in fact our first differences. And that's also our rate of change. And if the first differences are rate of change, these are the same number, this is going to be linear. If they are not the same number, if your y values are going up by different numbers, then it's going to be nonlinear. So now I want you to go over to the next question and try this one on your own. Find your first differences between your y values and see if this is a linear relation or a nonlinear relation. And if you calculated your first differences, you should have done 0.27 minus 0.33, 0.21 minus 0.27, and continued that. You should have gotten that the first differences is equal to negative 0.06, and this is our rate of change. Since these are all the same number, this is a linear relation. And now let's look at an equation. When you have an equation of a line, it's going to be in the form of y equals mx plus b. And this is called slope y-intercept form because it directly gives you your slope and your y-intercept. So in this equation, y equals mx plus b, y and x are just any point that's on the line, any coordinate on the line. M, that coefficient that's in front of x, that's going to be known as your slope. and B is the y-intercept. So let's just draw a quick graph here. If this is our line, this starting point right here that you might have called your initial value point, this is actually that y-intercept. The y-intercept is the point where your line is going to cross the y-axis. So this is our y-axis, that vertical axis, and here's our line, that point where that intersects the y-axis, that is your y-intercept. And slope is just a measurement of how steep your line is. Slope is actually the same thing as our rate of change. And you might be more familiar with the y-intercept as the initial value. Or you may have considered it to be the starting point, but it's always going to be that y value when x is 0. So let's look at identifying the slope and the y-intercept from equations. So if we have this equation right here, y equals 3x plus 2, that coefficient in front of your x is always going to be your slope. So in this case, our slope is 3. And then our y-intercept is always the number that's on its own. So our y-intercept is 2. And that would be the point 0, 2. It's always going to be the point 0 and then your y value. So let's try another one. We have this equation y equals 3 over 4x minus 2. So that coefficient in front of the x, that's always your slope. So our slope is 3 over 4. And our number that's on its own is a negative 2. It has that minus out front. So it's going to be negative 2. And the actual coordinate of the y-intercept is 0, negative 2. Now let's actually look at creating equations when we're given the slope and the y-intercept. So remember, the equation is y equals mx plus b. M is our slope, b is our y-intercept. So when m is equal to negative 2 and b is equal to 6, our equation would be y equals negative 2x plus 6. And let's do another one. When m, our slope, is equal to 1 and b, our y-intercept, is 3, our equation is going to be y equals 1x plus 3. And we wouldn't necessarily have to include this 1 in front of the x. And let's actually try one last one. So when m, our slope, is equal to 0 and b, our y-intercept, is equal to negative 5, our equation would be y equals 0x minus 5. And then what happens when we have 0 times x? Well, that's just going to be 0. So we don't actually have to include that. Our equation would just be y equals negative 5. So there are more questions that you can practice creating the equations and also identifying your slope and the y-intercept. But let's move on to finding the slope when we have 2 points on the graph. So if I would like to find the slope between these 2 points, 1 and 2, 3 and 5, I can draw out these points. So a little review in coordinates. Your first number is your x, your second number is your y. So on our x-axis, that's always horizontal. This is where 1 is, but then we gotta move up to 2. And this is where our point is. If we drew a line straight to the x-axis, it crosses the 1, and if we drew a line straight to our y-axis, it crosses that 2. So let's draw that next point 3 and 5. So this is where 3 is, and we have to go up to 5. And that's our next point. So here's our line. And I draw these arrows because it can continue on forever. Now we've actually done this before. We have found the rate of change from graphs, and rate of change is the same thing as the slope. So we can follow the same process. if we drew a triangle underneath these 2 points, we would then want to find the change in our y values, and our vertical line is always the y values. So our change here would be 5 minus 2, and that's 3. And then we also need to find the change in our x values, this horizontal line. So we can just do 3 minus 1, and that's just 2. And the way we would compare these is we would do the change in the y values over the change in the x values. But another quick way to remember this is that slope is equal to rise over run. And because slope is known as the steepness of a line, this is a nice way to remember it. So rise is our y values, our change in our y values, and run would be the change in our x values. So in this case, our slope would just be 3 over 2. And I'll show you another way to find your slope from the line on the graph without drawing this triangle. So after you draw your 2 points, you would want to pick one point to be your starting point. So if I choose my starting point to be this one down here, 1 and 2, I would need to find a path to the second point. And I can only go up and down and left and right. So since I know that slope is equal to rise over run, I can only rise up or down and run left and right. So this is where our starting point is. To get to the second point, from our starting point, we can rise 3. So we're only going up 3, and then we would run 2 to the right. So one thing to note, if we go up or to the right, it's positive. If we go down or to the left, it's negative. So we went up and right. That means our rise and our run are both positive. So we rose 3, we ran 2. So our slope is still 3 over 2. So that's the second way to find your slope from a graph without drawing this triangle. And I'm actually going to show you one more way to find the slope using the 2 points and without drawing the graph. So our 2 points are 1 and 2, and 3 and 5. And we know that slope is just equal to rise over run. So the rise represents our change in our y values, and the run represents the change in our x values. So there's a formula that we can follow, and it's y2 minus y1 divided by x2 minus x1. So these are just our coordinates. So if I have 2 points and I pick one to be my first point and the other point to be my second point, if this is my first point, 1 and 2, the coordinate would be x1, y1. And our second point would just be x2, y2. So this is what you're going to put into that formula. So our formula for slope, and we usually use m to represent slope. Our formula is y2 minus y1. That's the change in the y values. And that's over x2 minus x1, our change in our x values. Our y2 is 5, and we need to subtract our y1, which is 2, and that's going to be over our change in our x values, so x2 minus x1, and that's just 3 minus 1. And then we can do this calculation. If we do 5 minus 2, that's 3, and 3 minus 1 is 2. And that was just our slope. So that was just 3 different ways to find your slope. So now I want you to pause the video and try this question on your own and come back to the video when you are ready to check your answer. You can use whichever method you might prefer to find your slope of a line. So I'm just going to run through this one with you again. So I drew 2 points here, and I'm going to just count my rise and my run. So remember, slope is just equal to rise over run. So you need to pick a point that's going to be your starting point. I'm choosing this one up here, and we need to make a path to that second point. So from this first point, we need to go down 1, 2, 3. And since we went down, that's going to be a -3. That's the rise. And then we need to run to the left or to the right. We're going to run to the right 1, 2, 3, 4 units. Since we went to the right, that's 4, +4. And so that means our rise over run is just going to be -3/4. And you may have chosen a different method to find the slope, but you still should have gone that the slope is equal to -3/4.